Open ANSYS Workbench. Click and drag Fluid Flow Fluent into the workspace. Right-click on the geometry and select New Space Claim Geometry. A new Space Claim Geometry window was opened. Next, click on the checkbox of End Sketch. From normal geometrical coordinates, select the sketch plane and select XY plane in the graphics. In sketching, select line and draw the line of 250 mm in Y-axis. Now select line and draw the line horizontal in X-axis of about 648 mm. Now select line and draw the line vertical in Y-axis at distance of 648 mm in X-axis and 285 mm in Y-axis. Now select a point in the XY axis and fix the distance from X-axis as 59 mm and distance from the 200 mm. Now draw the curve using the spline starting from the convergent corner to the divergent corner. Adjust the curvature of the spline by pressing Escape button 2 times. Next, exit from the sketch plane. Now the space claim is having the axisymmetric convergent divergent nozzle. Close this window. Now right-click on Mesh and click Edit. Mesh window was opened and right-click on Mesh and select Sizing. Geometry selection, click and click the fluid domain got selected. In face sizing, give the value of 0.005 m. Now right-click on Mesh and give Generate Mesh. Mesh has been generated. Now select the first edge and right-click and select Create Name Selection and give the name as Inlet. Now select the second edge downstream and right-click and select Name Selection and give the name as Outlet. Now select the third edge curve and right-click and select Name Selection and give the name as Wall. Finally, select the fourth edge and right-click and select Name Selection and give the name as Symmetry. Also, select the surface and right-click and select Name Selection and give the name as Fluid Flow. Now in the project tree, name selection boundary conditions are verified by selecting appropriate sections. Close the window. Now right-click on Mesh and give Update. Select Setup in the workspace and right-click and Edit. Check the double precision and press Start. It took some time to open the Fluent setup completely. After loading a fluid domain model into Fluent Setup, go to Models. Double-click on Viscous Flow and change the model to Inviscid Flow. Double-click on Energy Equation and check Energy Equation checkbox. Double-click on Boundary Conditions. Select Inlet and edit parameters as Pressure Inlet and give 225,000 pascals for supersonic gauge pressure and 266,700 pascals for total pressure. Also temperature 293 K. Select Outlet and edit parameters as Pressure Outlet and give total gauge pressure as 34,100 pascals and temperature as 170 K. Check the symmetry. Check the nozzle curve as Wall. In reference values, select Compute from Inlet. Double-click on Residual Monitors and change the convergence values of absolute value to order of 1 times 10 to the power of -6. Double-click on Initialization and select Hybrid Initialize. Double-click on Calculation Activities and select 1 for autosave every iterations. Give number of iterations to 4,500 and click on Calculate. Now the solver is running. After getting solutions, double-click on Contours and select Velocity and Mach number and click on Save Plot to visualize the Mach number variations. Double-click on Contours and select Pressure and Static Pressure. Click on Save Plot to visualize the pressure variations. Double-click on Contours and select Temperature and Static Temperature. Click on Save Plot to visualize the temperature variations. In post-processing, select Contours and select Locations as Symmetry 1 and click on Apply to see the pressure contours. Similarly, you can double-click the XY plot and enter the value pressure and select the fluid flow wall to visualize the pressure variation. Double-click the XY plot and enter the value temperature and select the fluid flow wall to visualize the temperature variation. Double-click the XY plot and enter the value Mach number and select the fluid flow wall to visualize the Mach variation. Thus, the simulation of convergent divergent nozzle at exit Mach of 2.0 were done.